So I found a quiz for Friday, so we will quiz Friday. Again, we're not really doing anything new today. I mean, we're going to add factoring in, but hopefully we already know how to factor. So we're going to add an algebra step to solving equations. Plus it's block day, so we'll have plenty of time to work on it, ask questions. Friday, there's nothing new, so I'll come in, we'll answer whatever questions you have, and then we'll leave the rest of the time for the quiz. It won't take the whole time, but you can have as much time as you want. Well, I say that, I'll probably cut you off at some time just so you're not taking forever. And then basically we have 2 review days. So not much new today, nothing new Friday, and then 2 dedicated review days. So if you're feeling good about things up till now, then you're going to be fine for the test. If you're not feeling good about things, you still got a few days to figure things out. All right, let's look at the notes for today. Solving trig equations algebraically, that's the same thing we did yesterday. Today's day 2 because we've added factoring sort of to the front end of the problem. So the back end of the problem is all the same as yesterday, but today there may be some factoring at the front. Yesterday and today, our goal is to solve the equation by isolating the trig function. Get the sine by itself, get cosine by itself, tangent, whatever, get that thing by itself. Today things are a little more complicated, so just make sure we use good algebra. Don't get lazy with your algebra. It's algebra, algebra, algebra today. I mean, you still got to know the unit circle, but assuming you know that, it's an algebra day. Sometimes when isolating the trig function, you must raise both sides of the equation to a power. So like if you have sine squared of x equals 1/4, then you would need to square root both sides. Square root both sides, you'd have sine of x equals, when you square root both sides, you got to remember the plus or minus. And that's what statement B is about. When raising each side to an even root, mostly talking about a square root there, you must use the positive and the negative of the other side, the plus or minus. So Roman numeral 1 in summary is, don't forget the plus or minus when you square root both sides. You know that, but if you haven't used it in a while, and especially if you're using it in a new situation with sines and cosines, maybe it gets messed up or forgotten. All right, the second type of thing is factoring. It's like half of the next blanks are either factor or zero.
On the blank where it says when this happens.
Okay, yeah. So when you get the plus or minus, what that means is you're going to use all 4 quadrants. So in some ways it's a little easier because you don't have to worry about all students take calculus, because if you're using the plus and the minus, you're just going to be in all 4 quadrants anyway. So in some ways these problems are, like, if you're iffy on the unit circle, you like these problems because you don't have to worry about where things are positive and negative, because you're just going to grab all 4 quadrants. All right, second method would be factoring. As with algebraic equations, we often need to factor a trig equation. First, get 0. Like, that's the important blank there. Manipulate the equation to get 0 on one side. Please do not factor unless you have 0 on one side. This is a crucial step. It's like we're repeating the same thing here. Don't forget to get 0 on one side if you're going to factor. Factoring to solve an equation Works only when you have what on one side? 0. That's a little bit repetitive, but it's repeated for emphasis. Get 0 on one side. Do not factor until you have 0 on one side. Sometimes you can factor right away, meaning it's already equal to 0. Look for a blank to factor out. So what goes in this short little blank if we're talking about factoring something out? GCF, especially if the word common is right there. So look for a GCF. It's usually the easy kind of factoring, but you have to be thinking about it to be looking for it. If you cannot factor right away, you may need to get your equation to have only one trig function. We'll see this in a minute. Like if it has sines and cosines and tangents in it, then factoring gets a little bit wacky or maybe impossible. And you may have to use trig identities. Mostly sine squared plus cosine squared equals 1. And the partners with that. The Pythagorean identities for that. I'm going to skip E because it's confusing unless we're working a problem. After you factor, you set each factor equal to 0 and solve like you did yesterday. So in theory, you know everything you need to know to work these problems. It's just now we're combining factoring with trig identities with the unit circle and kind of dumping it all into one problem. Let's do some examples. It's one of those days where if you're good up till now, it's nothing new today. But if there's a weakness somewhere in the background, we might find it today. Solve 18 cosine squared x equals 9. So what do you want to do? What do you want to do first? Isolate cosine. So how would I do that? What would we do first? Let's divide by 18. So cosine squared x equals 9 over 18, which is 1/2. All right, what would you like to do next? Square root both sides. So cosine of x equals plus or minus, that's the big deal for this problem. The square root of 1/2, square root of 1 is 1, the square root of 2 I'm sort of stuck with, but this is good news. We're like one step away from good news, because what do I need to do with that? Yeah. Fix it. It's not called a conjugate, but rationalize the denominator is the fancy term. I don't care that you know the fancy term. I do care that you know how to do it. Plus or minus root 2 over 2. What's the denominator for where the cosine is root 2 over 2? Is it shallow, middle, or steep? Middle, and so what does that mean the denominator is? 4. And because it's plus or minus, it's like, well, I don't care. It's in all the quadrants, so I need all the 4s. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So that's the one I mentioned where sometimes the plus or minus actually makes your life easier. It's just all of them. You don't have to worry about who's positive and negative. Number 2. Find the values between 0 and 2 pi which satisfy this equation. 2 sine x cosine x plus cosine x equals 0. I don't know that I really needed to write it again. So do you see what we can do with that one? It's got sines and cosines in there, but we should always look for a GCF first. We can factor out a cosine. Now be careful. If I take cosine off of the first term, I get 2 sine of x. That's the easy one. This next one, some people mess up because they're like, oh, I took the cosine, so there's nothing there. Like, no, that's not quite right. What do I need to put there? Plus 1. Right? We are undistributing, so I need the plus 1 there so that if I did distribute, I'd get back to where I started. So, again, it's a kind of common mistake that if only 1 is left, people think, oh, I took the cosine, so it's just gone. Well, the cosine's gone, but you need that 1 that kind of holds the spot there. Two factors, both equal to 0. So either the first factor is 0 or the second factor is 0. Now we just have two problems to solve. Where's the cosine equal to 0? No, because at 2 pi, the cosine's 1. Yeah, the other. So you're right that it's a quadrant. It's the up and downs. Pi over 2 and 3 pi over 2. And the other one, sine of x equals negative 1/2. What 2 quadrants are we looking in? 3 and 4. Over 6. Great way to answer that, or to start the answer to that. So 7 over 6 and 11 over 6. Ooh, secant, number 3. Let's start picking on people here. Joseph, any idea what we should do first on number 3?
Factor out of tangents.
Factor out of tangents, yes. So if I take the tangent out, Brandon, what's left in parentheses if I take the tangent out? Good, secant x minus 2. So then I set each of the pieces equal to 0. Tangent of x equals 0. Secant of x minus 2 equals 0. All right, Landry, where is the tangent equal to 0? Maybe it's helpful to remember that tangent is sine over cosine. So if you knew where sine was 0, then that would make tangent 0. That's how I answer that question, because I don't have the tangent memorized very well.
So,
0 and 2 pi is right, and it does say include 2 pi, but also pi. Okay. So yeah, you guys are like me. You don't have all the. I think you have the sines and cosines memorized pretty well. Tangents is a little trickier, but think back to what tangent is, and then you can go from there. Okay, on the other one, secant of x equals 2. That really doesn't do me any good. How could I rewrite that to something helpful? Yeah, cosine of x equals 1/2. Use the flip thing. So, Austin, where is the cosine equal to 1/2? You can tell me quadrants, you can tell me denominators, you can tell me shallow, middle, steep. Give me going here.
The first and the last one.
Okay. So first and fourth, I like that. We'll let you off the hook with that. Cole, I still need the denominator though, or shallow middle steep. That's kind of the same thing. For cosine is 1/2.
Over 3.
It is over 3. So, Luke, what's over 3 in the first quadrant? Pi. And we'll just go through all of them. Toby, what's over 3 in the fourth quadrant? What's that? 5 pi over 3. Yep. So factor first, and then it basically turns into 2 problems. And usually each of those have 2 answers, but sometimes more or less, depending on what's going on. All right, number 4 is a little different. We haven't done one like this before. It's got all cosines. Oh, let's move the 1 over. Okay, so I want to factor that. That looks a little bit like it's the first term squared and the second term is not squared. So it looks a little bit like that. 2 times the first term squared minus 3 times the term plus 1. So it's got to be 2 cosine and cosine for the first terms. Oh, this one's not too bad. Because to get 1 on the other end, it's got to be 1 and 1. And then how do I make the signs work? Yeah, negative on both. So that would be the inside would be negative cosine. The outside would be negative 2 cosine, which would make negative 3 cosine. If you struggle with that, there is shortcut's not the right word. More of a long cut. You can say, I don't like factoring with cosine. I want to stick a u in there. So 2u squared minus 3u plus 1. And if that's easier for you to factor with u's, that's fine. And then you put the cosine back in for u, and you get what we got. So if it's really ugly and you're struggling with it, it's okay to put u's in there and make it look nicer. And then when you get, after you factor it, you're like, okay, I gotta now deal with the cosines. So that's called u substitution. Some people use it all the time. Some people never use it. Most people, it's sort of like, well, if I can figure it out, then I'm not going to bother with it. But if it looks complicated, I'll put some u's in there and see if I can make sense of it. All right, so set each factor equal to 0, and now it's turned into 2 problems from yesterday. Cosine of x equals 1/2. Cosine of x equals 1. So let's see. Angel, where's the cosine equal to 1/2? Well, what quadrants, first of all? And?
Second.
Cosine is the x-coordinate, so it goes left and right. So if it's positive, it means it's on the right. So first and fourth. Actually, this is the same problem we just did a minute ago. Cosine x equals 1/2, that's pi over 3 and 5 pi over 3. Cosine of x equals 1. JD, where does the cosine equal 1?
Pi over 2. No. 0. pi plus 2 pi.
You're 2/3 right. It's this spot, you're right, which is 0 or 2 pi,
Oh, it can't be that.
but not pi, because that'd be -1. So just 0 or 2 pi.
Okay.
Which is, this one's kind of weird because that's kind of the same spot, and we don't usually, this is the only place where we give two answers for the same point. Does that make sense? That's the only place where we do that. Number 5. 2 cosine cubed equals cosine. Well, let's set it equal to 0 first. All right, what do you see we can do for that one? Good, take out a cosine. And if I take out a cosine, then I need to know what goes in the two spots there. So, Danny, what goes in the first blank? Good. And Derek, in the second blank? I'm factoring out the cosine.
1.
Just 1. So then I set my two factors equal to 0. And I've got a problem, or two problems, I guess, like yesterday. So cosine is 0. Cosine is 0. Gregory, where's the cosine equal to 0? What angle has a cosine of 0?
Pi over 2 is 3 pi over 2.
Good. Pi over 2 and 3 pi over 2. So there's part of our answer. Cosine squared x equals 1/2. We square root both sides. Square root, don't forget the plus or minus. Which is the square root of 2 over 2. We did this problem a minute ago, I think. So the plus or minus means I don't care about quadrants. I'm in all of them. It's all the over 4s. So that problem all told had 6 answers. Number 6. Oh, what do you see about number 6? Do you see why number 6 is on here? What's different about it? The 2x. That means I got to come up with those extra answers. I got to double my number of answers. So I don't know that means 4 answers because of the squared, so who knows? Let's just see what happens here. Tangent squared of x, tangent squared of 2x equals 1/3. So tangent of 2x, if I square root both sides, plus or minus square root of 1/3, plus or minus root 3 over 3. So where does the tangent, again, we ignore the 2x for now. We want to figure out where is the tangent root 3 over 3. It's plus or minus, quadrants don't matter. What are the, actually, I may not want to list it twice because I'm not worried about quadrants. So what's the denominator for root 3 over 3? 6. And I just want all the 6s. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And I'm starting to write small because this double means what? How do I get more answers? Add 2 pi to all of those. So I'm going to end up with 8 answers on this thing. So 2 pi would be 12 over 6. So I need to add 12/6 to all of these. So 13 over 6, 17 over 6. I should have planned ahead better. 23 over 6. No, I missed one. 19 over 6. And then 23 over 6. This time I'll plan ahead and start a little further left. Divide them all by 2, which is multiply them all by 1/2. And none of them reduce, so I'm just going to change all those denominators to 12. So everything, all the same answers, just over 12. Y is what? Be more specific if you can.
Why are you changing the denominator from 6 to 12?
Somebody answer that. Why am I changing the denominator from 6 to 12?
So they're small enough to be inside
Okay, that's a good answer. So they're small enough to be between 0 and 2 pi. But why am I dividing by 2? That 2x. So 2x equals all those things. So to fix the 2x thing, I would multiply by 1/2. And so that would make all my denominators 12. So I got 8 answers on that one. Yeah, that makes sense. Normally I'd have 2 answers for a problem. But the plus or minus made me get 4 answers. And the 2x doubled it. That got me to 8 answers. Crazy one. All right, last one. What are the x-intercepts? What's x-intercepts mean? Set y equals 0. So really this is a different way to ask the same question. So 0 equals all of that. You see what we need to do or what we can do first on that? Factor out the sine of 2x. And then set both of those equal to 0. I'm going to bail on this problem because there's nothing new in this problem. It's got the doubling thing, it's got the plus or minus thing, but that's fine. What about sine of x equals 3? Where does that happen? Let's see. Sine goes between -1 and 1. So if you get sine of x equals 3, it's just no, that you can't do that. No solution would be the fancier way to say it. No with exclamation points. Look at your worksheet, because this is what I was afraid was going to happen. We didn't hit one of these. So go to worksheet 3, and we need to do number 10. Worksheet 3, we need to do number 10. Because we haven't seen one quite like that. Secant squared minus 2 tangent squared. Like I can't factor that. There's not a GCF. But there is some relationship between secant squared and tangent squared. And it's been a few weeks, so I definitely don't remember what that is. So I'll start with sine squared plus cosine squared is 1. If I divide everybody by cosine squared, tangent squared plus 1 equals secant squared. And maybe some of you have that. Maybe some of you have all three of them memorized, but I really don't. I just always start with sine squared plus cosine squared equals 1 if I see squared showing up, because then I know it's one of those Pythagorean identities. I could use this a couple different ways, I guess, but it looks like the easiest way would be to just, in place of secant squared, put tangent squared x plus 1. Because secant squared equals tan squared plus 1. Yeah, that works. And now I've got tangent squared minus 2 tangent squared. That's negative tangent squared. Plus 1 equals 0. We're getting close. I'm going to move the tangent squared over, but then write it like this, so they're both positive. And now we are on the doorstep here. Evan, what do you want to do next with this problem? Okay, I like that. Square root it. Oh, except that's not, I mean, you were right. What I wrote was not exactly right. Emma, what's not quite right about what I've written? I mean, Evan was right. I need to square root both sides. And I put the square roots on, but I left something off. When you square root both sides, the plus or minus. So I probably should have written that as soon as he said square root, plus or minus 1. Jake, where's the tangent equal to 1? What's the shallow middle steep, or what's the denominator? I'm not worried about quadrants because it's all the quadrants. Over 4. I know it's over 4 because it's in the middle. I'm not really concerned about plus and minus because it's all of them. It's all the over 4s. So just so that we get to everybody, Noah, give me 2 of the answers.
Pi over 4, 3 pi over 4.
Okay. And Austin, give me the other 2 answers. Mm-hmm. Yes. Oh, there was one stick left. Cecilia got off without having to answer a question. What could I ask you? Oh, how would I find so here's one of the Pythagorean identities. There's the other, or one of the others. How do I find the third one if I wanted to find the third one? Divide by sine squared if you need the third one. So that would end up being 1 plus cotangent squared equals secant squared. Thank you. That way we got to everybody. All right, still plenty of time left. Your assignment today is worksheet 3, 14 questions. That's the only one that had the weird substitution on it, I think. Yep. So plenty of time to work. Reminder that you will have a quiz on Friday, and the quiz will be part calculator and part no calculator.